Let's go ahead. We're going to look at one more example here from section 4.4. We're not asked to solve it all the way out, but they simply want us to find the form of the particular solution for the following ODE. It's the fourth derivative of y plus y triple prime equals 1 minus x squared e to the negative x. Again, they only ask for the form of the particular solution, but we know that we should always be very careful and actually begin by finding the complementary solution first. So let's find y sub c first. So we're going to solve the homogeneous ODE, y to the fourth derivative of y plus y triple prime equals to 0. The auxiliary equation would be m to the fourth plus m cubed equals to 0. We can solve this by factoring. Factor out the m cubed. This equals to 0. Set each factor equal to 0, and we find the following. We have 0 is a solution of order 3, and then we have m equals to 1, which would be a solution of order 1. So what this tells us is that our complementary solution is going to be C1. If you want to put the e to the 0 first, sometimes I find the consistency helps some students. Typically I would not write this. I would just go right to the next line, but if it helps you can use it. Because of that repetition, we're going to have some powers of x multiplying to this. So you kind of see explicitly the m in the exponent of the e, and then plus c4 e to the negative x. E to the 0 power is still going to be 1, so it really looks like c1 plus c2x plus c3x squared, and then plus c4 e to the negative x. Now we would turn our attention to, if we were going to solve it all the way out, we would turn our attention to finding, that's weird, sorry about that, our y sub p. So we now look at the right hand side of this ODE, our function g of x. Some of the highlights include what looks like a constant function. So it looks like we would have a constant function, it's a polynomial, a, and then it looks like we would also have a power of x squared e to the negative x. So I could write that down. And now this is where we have to be really careful, because some of these terms are definitely kind of shared. And actually, furthermore, I forgot to write this, but because it's an x squared times e to the negative x, we could have that polynomial. Okay, so as I was saying a moment ago, because we have the x squared e to the negative x, here, it would be a polynomial of degree 2 times e to the negative x. So I'm going to write it two different ways. I'll put the b x squared, then we could have a cx jump to e times e to the negative x, or I think for some people it's more helpful to write the terms individually. We have a bx squared e to the negative x plus cx e to the negative x plus e times e to the negative x. However, when we compare this proposed y sub p term to our y sub c term, we see that there is quite a bit of overlap here. In particular, we have a constant as a part of y sub p and a constant as a part of our complementary solution. Therefore, as our directions were, we need to multiply this by the smallest power of x to the n, such that it won't have any overlap with y sub c. Well, we already have the constant term, can't have that. We have x squared, so the smallest power of x that would work would be x cubed. And we also kind of run into the same issue here. We have a constant times e to the negative x. Well, there's also a constant times e to the negative x in this part as well, which means that we're going to multiply this entire thing by x. I think in some regards, and this is why I like to sometimes write it as above, it makes more sense when you see it like this, that the x is going to get multiplied to that entire piece. But another way to think of it is, if I were to just focus on this piece, and making sure that it didn't overlap with my complementary solution, then of course I'd have to multiply that by x. Now the issue then becomes is that this new piece multiplied by x will have some overlap with this piece, which means then that that thing would also need to get multiplied by x, and then this thing would have some overlap now with this piece, which means that this too would need to get multiplied by a power of x in order to be linearly independent. So what we're going to end up getting is going to be b, this now gets bumped up to x cubed e to the negative x, plus cx squared e to the negative x, plus ex e to the negative x, and this would be our form of the particular solution for this fourth order linear ODE.